Hey, let's begin our last lesson of this unit. Our goal today is to be able to apply the properties of mathematics and try to be comfortable with doing some mental math. So we have a lot of notes with this one, so let's get started. Today's date and page number should also be in your notes before moving on. So your warm-up, I have, we'll make it even easier for you. Just do number 1. Don't even worry about number 2 or number 3. I just want you to choose, using these, which one would you do for mental math, and all you have to do is circle the one or write down the one in your notes of which you think would be better. So if I asked you to do mental math, would you rather do 25 times 24 or 25 times 4 times 6? And same with the next two. If you had to do it in your head, which way do you think would be easier? Go ahead and write those down, and when you're done, come back. Okay, so I'm going to guess most of you chose the ones on the right side where my cursor is because it's broken down into smaller chunks that you can work with. Now, those are different properties of math that we're going to learn about today, and I wanted you to just kind of see different ways that you can look at them so it doesn't look like it's one whole big number. We can break these things down and try to make it a little more manageable. All right, let's talk about how you can use big numbers and be manageable. Here is a person who showed that mental math can be done in your head pretty easily with even bigger numbers. So this guy's name is Daniel Tammet, and he's extremely good with mental math. He was once asked to calculate 37 to the power of 4, or 37 times 37 times 37 times 37. Within under a minute, he was able to figure out that it's 1,874,161. And if you don't believe me, get out a calculator and try it. He was actually able to do it under a minute, which is pretty impressive. How was he able to do that? Well, what he did is he used mental math strategies, and I'm going to try to teach you some strategies not to be able to do a number this big, but to be able to do simple math from little more challenging numbers than just like 10 times 2. Okay? So let's get started. All right, there's 4 different properties we're going to look at with a bonus one in mind. All right, so the first property we have, we call it the commutative property. So these properties are rules. These are rules that you can follow with adding or multiplying. So let's put commutative property in our notes. And basically what commutative property is, it's ordering. So I put it in parentheses. It's how you order things. Now with adding or multiplying, the word's description of commutative property, this would be like the definition, you can add or multiply numbers in any order. It doesn't matter. So I give you 2 examples, one adding and one multiplying. So the adding example I give you is 18 plus 9 equals 9 plus 18. Doesn't matter what order you do 18 plus 9 in, you're going to get the same answer. 15 times 2 is the same as saying 2 times 15. So those 2 equations you see there balance because both give you the same answer. Before moving on, make sure you have this down and then hop on back for the next property. All right, associative property, we call this the grouping property. So the big difference between this and the other one is commutative property really only deals with 2 numbers, 2 add-ins or 2 factors. Associative property, you can basically what it's telling is when you're adding or multiplying and you have more than 2 numbers, you can group them any way you want. So grouping, I use parentheses, and you can see here that I decided that 17 plus 2 could be in parentheses for the first one, and that equals the same amount as 17 plus 2 plus 9, which is in the parentheses of the second one. It doesn't matter what way you group them, you're going to get the same answer. Multiplying is the same way. I could do 12 times 2 first and then multiply by 4, or I could do 2 times 4 first and then multiply by 12. It really doesn't matter. But if I have 3 or more numbers and I'm trying to find a way to group them when adding and subtracting, either of these would be fine. So go ahead and write this down in your notes before moving on. So one of the things you probably noticed with grouping here and ordering in the other one, or associative here and I forgot, commutative there, you see with both of these, nothing has subtracting or nothing has dividing. These rules or properties would not work with dividing and subtracting, but they will work with the adding and multiplying. Now, that's the big thing I wanted to warn you about. You don't need to write this down, but I do want you to be aware there are no cool rules that we can use with subtraction and division to make math easier, but we can definitely do adding and multiplying, so that's half the battle. The next property is called the distributive property, and the reason I don't have anything in parentheses is because I also just call this the distributive property. So the definition of this is basically to multiply a number by a sum. You're going to multiply each number in the sum and then add. So this is just for multiplication, and what you can see here is I did 6 times 10 and 6 times 10 plus 4. So basically what we're doing here is we're sharing. So the 6 can go with the 10 and the 6 can go with the 4. So you could regroup it to have two separate multiplication problems, 6 times 10 and 6 times 4. You could also probably call this the sharing property, and it's only for multiplication. So why would you do this? Well, the math's a lot easier. 6 times 10 you can do in your head, that's 60. 6 times 4 you can do in your head, that's 24. And adding 60 and 24 is really easy. In the other side of the scenario, you'd have to do 10 plus 4 first, which would be 14, and then multiply by 6. I'm pretty good with my math facts, but 16 times 14 takes me a little longer in my head. If I was looking at it as 16 times 10 and 16 times 4 and then adding them together, it's a lot easier. So this is called the distributive property. Go ahead and write this down in your notes as well. All right, the fourth property that you're going to write down is called the identity property. This only works with multiplying and adding, and basically the words or definition for multiplying is the product of any number times 1 is that number. So the identity property stands for 24 times 1 being our example. 24 is going to be the answer no matter what, because anything times 1 is itself. Now with math, when you talk about adding, we also with the identity property have the identity of 0. Okay? Whenever you add by 0, you always have the same sum be the other number, the other addend. So 13 plus 0 is going to be 13. There's no difference around it. If you add by 0, it doesn't change the number. So these are the two identity properties for 1 and 0. These are some of the things you probably learned first with multiplying and first with adding, but it actually has a rule. It's never going to be different. Write this down before moving on. All right, I have one more property, and that is the property of 0. So this works with multiplying, and it only applies to multiplication. Anytime you multiply by 0, the product is going to be 0. And can you divide by 0? No, only Chuck Norris can divide by 0. I had to get a Chuck Norris punch in there somewhere. So this is Chuck Norris approved. You don't have to write down the bottom, just write down the top. So you remember, anytime you multiply by 0, the answer is 0. All right, I want to challenge you a little bit before you move on. I want you to do a box of thought here. I want you to give me an example of a commutative property and an associative property. And it can't be the same example I just had in my previous slides. Make up your own. Then I want you to name some situations in which you might do mental math. Just give me one, really. Name a situation where you might use mental math. And for 3, I know we didn't cover this, but what do you think the rule of 0 is in relation to division? I know I said that only Chuck Norris can divide by 0, but can you divide by 0? What is the rule of it? See if you know. So give me the answers to 1, 2, and 3 before moving on. Okay, so now it's time for us to do some practice. I think this got messed up. Give me a second. Here it is. Okay, so this is the first practice we have, and here we're going to use the properties to add and multiply the whole numbers. All right, so if you look at a whole list of adding here, you're going, good grief, 17 plus 5 plus 3 plus 15. Hey, I know what I can do. I can chunk some of these mentally. And you're probably looking at it already and already figured out how you can mentally chunk some of these numbers together because you know how to add up to 10 pretty easily. So if you thought that you could take 17 and 3 and chunk that together to get 20, and you could chunk 15 and 5 together to get 20, you're on the right track. That's exactly what I did here, and that's called the associative property. First, I used the commutative property to identify that I can move these around any different way. It doesn't matter at all. And then I used the associative property of actually grouping these into smaller sections. So I know 17 and 3 is 20, 5 and 15 is 20, and look at that. 20 plus 20 is 40. A lot easier if you than trying to go 17 plus 5 is 17, 18, 19, 20, 22, plus 3 more is 25, plus 15, 25, 35, 40. But if I look at it and go 17 and 3, 20, 5 and 15, 20, 20, 20 is 40, you can be a lot faster with it. So I want you to copy this down in your notes so you can have an example of how we regrouped it. However you feel you need to write these notes, go ahead. You could copy all of it down, or if you already kind of get the hint of it, make sure you at least write the parentheses part and identify that this is associative property, because you're going to have to tell me how you know the different properties. So do that before moving on. Let's look at another one. Now this one is multiplying. So I can regroup any way I want. So let me show you how I did this. I looked at it and I said, well, 4 times 13 times 5, I want to look for products that are multiples of 10, something that I can put together real easy. And I recognize, well, I can do 4 and 5 pretty quick in my head. 4 times 5 is 20. So I regrouped or used the associative property to do 4 times 5, giving me 20. And now I have to do 20 times 13. You're like, how can you do mental math that quick? Well, I know that 13 times 2 is 26, and then all I have to do is add a 0 to it, and that's how I get 260. Mental math, sometimes you got to write your steps down so you don't get lost, but it helps you to see that you're going to go a lot quicker. Now, you probably did a lot of this in your head already, but you're realizing there's a rule to this. This is called the associative property. Commutative property, I can reorder them, and associative property, I can put them into parentheses if it makes it easier. It's just solving numbers. So the next practice I want to show you here is going to be using the distributive property. So this one you are going to want to take some notes. Now, if you remember back previously in our video, when I showed you distributive property, you can see that you can take a number like 14, you know, if we add this together, it gives you 14. You can borrow a number like 6 into each place value, the 10s and the 1s, and be able to do math quicker. So that's what we're going to do here. So what I'm going to do is I'm going to have the 6 work with the 10s place value, which is 30, and I'm going to have the 6 work with the 5 place value, which is 5. And I can do mental math with these, because I know that 6 times 3 is 18, but since it's the 10s place value, I add a 0, so I have 180. And 6 times 5 is 30, so all I have to do is add 180 and 30, and that gives me 210. Show you how I did that. So first I broke it apart. I broke 6 into 30, 6 into 5, and here it is, 6 times 30, 6 times 5. That's the distributive method. I can do these in my head. 180 plus 30 equals 210. Now sometimes you might have to stop and actually write down 180 plus 30 and then write 210. But you can do these things even quicker by using this mental math wizardry we call the properties. Write this down before moving on. And again, if you're going to write down anything, make sure it's the example of this. So you can see how I shared 6 with 30 and 6 with 5. All right, let me show you one more distributive property. You don't need to write this down. But I'm going to borrow 9 into 80 and 9 into 7. Because I know what 9 times 8 is. That's 72. I'm just going to add a 0 for 720. And I have to add that to 9 times 7, which is 63. When I look at them as smaller parts, I can do the math a little quicker. Now this is one of those scenarios where I couldn't do this in my head. I'd have to write down 720 and then 63 and then put them together just so I can physically see with my brain and my eyes that this makes 783. But I can make it go a lot quicker than trying to do those lattice boxes or the long properties of math. I can do this a lot quicker just using some mental math. So again, you don't need to write this down. I just wanted to show you it. All right, I already had you do a box of thought earlier, so I'm not going to make you do it again. But what I want you to do is I want you to solve all these problems and try to use the mental math tricks that we looked at earlier. Is there a way you could chunk these numbers together using the associative property to make it easier for you for 1, 2, or 3 with adding? Is there a way that you could share 8 into 10 and 8 into 2 to be able to figure out how to get that answer? So I want you to use your mental math. Come to me when you have these all done. Can't wait to see you get all these correct so you can get moving on to your homework and you have finished all the lessons for the first chapter. Give yourself a pat on the back for completing that. All right, we'll see you later.